Hi, and welcome to 4.4 Unit Conversion Prefixes. In this lesson, students will be able to convert between SI unit prefixes using dimensional analysis, or multiplying by a conversion factor. So before we talk about prefixes, we should talk briefly about what they're used for or used with. The SI units. SI stands for System International D Units, or the International System of Units. These 7 base units, or a combination of them, like if you do physics, if you're multiplying some of these together, um, they're used to describe every quantity in the universe. Pretty crazy. So for example, length, what do you think the SI unit for length is? I'll give you a hint. It's not a foot or an inch. It's a meter, okay? How about for mass? It's actually a kilogram. So instead of meters, we use feet. And instead of kilograms, do you know what the other version of a kilogram is for mass? You, the slugs in America to measure mass, you could use slugs. That's so weird. Let's just use metric. Time is measured in seconds. How about this one? What do you think electric current is measured in? Some people say voltage. It's actually an amp or an ampere. Okay. How about temperature? What do you think the SI unit is for temperature? Some people say Celsius. It's actually Kelvin. Okay. Definitely not Fahrenheit. Luminous intensity, we measure with candelas, and the amount of a substance is measured with moles. Those are the SI base units. So what can you pick out something that is different? One of these things is not like the other. Okay? What is the one that's different? Look at this. The base unit for mass is measured in kilograms. It has a prefix in it. So in physics, we want to make sure all of our mass quantities are in kilograms, not grams. Everything else, there's no prefix for those. So let's talk more about prefixes. There's a whole table for them in your reference table. It's on the 3rd page in the reference table. And it looks something like this. So when looking at a reference table like this, I always look for the centi because I know that there's 100 centimeters in 1 meter. That's just something that was ingrained in me when I was in grade school. Centi, like centennial, 100. So there's 100 centimeters in 1 meter. Let's see what they tell us about centi over here. I was expecting to maybe see 100. So what does this weird decimal and 10 to the 2 represent? Pause the video and think about it. So 1 centimeter is equal to this many meters. That's what they're showing you. They're showing you the conversion factor. 1 centimeter is equal to 0.01 meters. These are all the base unit equivalencies. So for example, maybe you know that 1 millimeter, there's 1,000 millimeters in 1 meter. Well, that means that 1 millimeter is equal to a very small amount, 0.001 meters. So another conversion that they're telling you, 1 millimeter is equal to 0.001 meters. But the better way to do it is really to look at this column. We want to say that 1 centimeter is equal to 10 to the negative 2 meters, and 1 millimeter is equivalent to 10 to the negative 3 meters. That's what they're showing you. These numbers are the base unit equivalences of one of these prefixes. Okay, and then they even tell you how to pronounce each one. I'm not going to go through the list. You could read it. This one's nice though, micro. And this is the Greek letter mu. You could pronounce it mu. All right. And then I mean, I guess we could come over here to for the prefix kilo. If I'm looking for something that's bigger, I kind of gravitate towards the kilo because you have kilogram and a kilometer. So I know that 1 kilometer is equal to 1,000 meters. And again, this is showing that these are the amount of the base unit. 1,000 meters is equal to 1 kilometer. That's how this table works, okay? And the reason they don't write meters in is because, wow, these prefixes work for any of the SI base units. All right, 1,000 grams is equal to 1 kilogram. What a convenient system for measuring things. Wow, I love that. You're not going to say a centifoot or a milli-inch. It doesn't make any sense. The prefixes, very efficient, great way to describe and measure things. I like to give some examples so you get an idea of how big these things are and how powerful the powers of 10 and these prefixes are in describing different things just by changing the prefix. So 1 picogram is the mass of an E. coli bacteria. 1 nanogram is the mass of an average human cell. 1 milligram is the mass of a mosquito. 1 centigram is about the mass of an adult housefly. 1 gram is about the mass of $1. So that's kind of like a good, you could get an idea for how much a gram is. It's the mass of $1. 1 kilogram is the mass of 1 liter of water. 1 megagram is 1 ton or a car. 1 gigagram is like the mass of the General Sherman, which is the largest living tree. 1 teragram is the mass of the Great Pyramid of Giza. So we're still using the same SI unit, the gram, but we're able to describe, look at this range of things just by using the prefixes in powers of 10. It's a really good system for measuring things. You could do the same thing with different SI units. Let's look at time. 1 nanosecond, or 1 billionth of a second, is the time it takes light to travel 11.8 inches, or about 1 foot. So you have 1 nanosecond is equivalent to 1 light foot, the time it takes light to travel a foot. Pretty crazy. That's the only example I use foot for because 1 centisecond, or 1/100th of a second, is the time for a hummingbird to flap its wings once. That's a centisecond. 1 kilosecond, or 1,000 seconds, is 16 minutes, 40 seconds. Okay? Look at how this jumps up. So we go from 1 kilosecond, which is 16 minutes, to 1 megasecond, or 11.6 days, from 16 minutes to 11.6 days. Now think of like kilobytes, a kilobyte and a megabyte. What do you think the next one is? Kilobyte, megabyte. It's like a gigabyte. And what do you think the time comparison? We went from 16 minutes for a kilosecond, 11.6 days for a megasecond, 1 gigasecond, or 1 billion seconds, jumps up to 31.5 years. So when we're talking kilobytes, megabytes, gigabytes, there's a big difference between them. Between each one is 3 powers of 10 different. And you could even go further, right? What's after a gigabyte? A terabyte, or in this case, a terasecond, is 31,558 years. Look how powerful using these prefixes are. Just by changing the prefix, we could describe a lot of different values of measurements. It's a very efficient system. Typically, when thinking of prefixes, we start with centimeter, millimeter, kilometer, right? 1 meter. So I had for time and mass, if you want to get a good idea for the powers of 10 and what these prefixes are like for length, I highly recommend watching this video, Powers of 10. It was made in 1977. I remember watching this when I was in high school. It's linked in the folder that this assignment is in. If you have time, I highly recommend watching it. It is classic. They do a great job. So let's put this into practice, okay? A student says that a desk is 225 centimeters long. How long is the desk in meters? I highly recommend using the reference table, getting used to that, and multiplying by a conversion factor like we have been doing. But I know you've already learned this. You've probably learned this acronym. King Henry doesn't usually drink chocolate milk, or maybe some other version of it, or maybe your teacher had you make up your own thing, which is great. That's very nice. It is very convenient. I'm not saying anything bad about this. All right, you take your decimal point, so that's centimeters. And then this even tells you the direction. Do I move the decimal point to the left or to the right? If you remember this acronym, it shows you. So we want to go from centi to meters, the base unit, meters. All right, so how many spaces are we going to move? One, two to the left. So you just go one, two to the left. That's 2.25 meters. That is very convenient. And it's another example of why I do like prefixes and the metric system because it is so convenient. However, there is a way to do what we have been doing. And even though this is an easy example, I recommend getting used to the table and knowing how to do this conversion factor thing. So let's take a look at the table and see if we could get to the same answer, 2.25 meters. So you just write the number down. We had 225 centimeters times. We want to multiply by the parentheses. We're going to do the same process using this table. So I see centimeters. I'm going to look at this row, okay? And before we said the way to read this table, 1 centimeter is equal to this many of the base unit. I'm going to use the power of 10 here, okay? So that's the conversion factor. 1 centimeter is equal to 10 to the negative 2 meters. Do you see where we're going with this? Where are we going to write centi? Top or bottom? It's going to be on the bottom so that they cancel out. We want to go into meters. This table tells you what to do. This table tells you, okay, for the centi, put 1. For the meters, put 0.01 or 10 to the negative 2. Okay? Boom. Centimeters cancel out, leaving you with meters, so we know we did that part right. And then you get 225 times 10 to the negative 2 meters. You could keep it in scientific notation like this, or you could actually do the multiplication and you get the same answer, 2.25 meters. So yes, that acronym method is convenient, but this is also a good way to do it. And I'll give you another one. It's a combination of convenience and using this table. So the question said, I'll write it over here, 225 centimeters. Another convenience factor of the prefix is you can replace this centi with this power of 10. What? It works like that? Yeah, it's the same. 225, replace the centi with times 10 to the negative 2, and then continue with the meters. That's how that works, people. The prefixes and the metric system is far superior to dealing with fractional inches and like feet, 6 feet, 7 inches. It's crazy. They're like, why are we not using the metric system? Anyway, let's do another example. It says convert 100 meters to kilometers. Using the acronym method, pretty easy. We're in meters. We want to go to kilometers. So how many spaces do we got to go? 1, 2, 3 to the left. So 100 meters, 1, 2, 3 becomes 0.1 kilometers. Very nice. No fractions or anything needed. But again, this is like a shortcut method. Let's try to do like the right way to do it. So the number we had was 100 meters, and we wanted to go into kilometers, which is 10 to the 3. So this is telling us that 1 kilometer is equal to 10 to the 3 meters. That is your conversion factor. Times, parentheses, write the unit on the opposite side, kilometers. One prefix is equal to that many base units. Easy peasy. All right. So that little trick I did before doesn't work now because we had 100 meters and I can't like, there's no prefix here. So that's only going like from the prefix to the base unit, but it's still convenient. All right. So the meters cancel out and you're left with 100 divided by 10 to the 10 to the 3, or 100 divided by 1,000, which still gives you 0.1 kilometers. Nice, nice, nice. Very good. The conversion factor method still works. So if you're in a pinch and you're not sure where to move the decimal, then you can still fall back to using this method and these powers of 10. Because look at this, you know, you're not going to move the decimal point 24 spaces. Like it's crazy. So sometimes you'll have to use a conversion factor. I'm using the easy example first to show you how to do the process. Once you know the process, you can apply it to harder situations. Example 3, an inquisitive student has a mass of 70 kilograms. Let's pretend like they know their mass is exactly 70 kilograms. They want to know what their mass is in micrograms because they're just inquisitive. They're like, hey, how many micrograms is my mass? Help them out. So let's see. We want to go from kilograms to micro. That's milli. Wait, okay. Okay, so that you could do this if you wanted to. The great monarch King Henry doesn't usually drink chocolate milk made near Poland, but this is not even an M. This is the Greek letter mu. So like now we're the whole acronym thing is really starting to break down for me. And then what if you want to go beyond this? You're going to remember all these different acronyms. And what if you want to do a power of 10 that's in between? Like it gets a little bit crazy here. So we're talking about kilo, you can do it, and then you want to go into micrograms, okay? So you want to go how many spaces? One, two, three, 4, 5, 6, 7, 8, 9. Who wants to do this? Okay, so that's where the decimal point is right here, right? So we got to go 1, 2, 3, 4, 5, 6, 7, 8, 9 micrograms. I mean, that's fine, I guess. That's a little babyish, though, to be honest. And then, oh, Mr. Nangle, what the heck are these lines about? It's because look at this, -1, -2, -3. It jumped to -6. So this is -4, -5, -6, -7, -8, -9, and like that. So like you have to remember to put the lines here. You have to remember a longer acronym. Let's just use the dimensional analysis, people. Now, I'm not going to lie, it is like an added step here because we to use the table, 70 kilograms, okay? These are the base units. So first, let's set up a conversion factor to go into grams. Okay, we want to get rid of these kilograms. We want to go into grams. So you look over a kilo, you say, okay, 1 kilogram is equal to 10 to the third grams. That's going to cancel out your kilograms. Then you're left with grams, but this student wants to know what their mass is in micrograms. So you just do another one, like we've been doing. You get rid of the grams, put it on the opposite side, and now we're looking for micro. That's over here. So 1 microgram is equal to this many grams, 10 to the negative 6 grams. And notice this is why I like the power of 10, because look at, they even gave up at writing. They could have continued to write, but they were like, that's too many zeros. Like, let's just use the power of 10. Okay, that's how this works, people. This is the right way to do it. All right, so again, reading the table can be a little tricky. It takes practice. One of the prefix things is equal to this many of the base unit things. I'm saying things because it depends. It could be any SI base unit. It doesn't have to be grams. Another convenience factor. Okay, so this becomes 70 times 10 to the third, or 70,000 divided by 10 to the negative 6, which will give you a big number because it's 70 kilograms into micrograms. It's going to be a lot of micrograms. And then look at this number that your calculator pops out. It's nicer. It's 7 times 10 to the 10, and then what are we left with? Micrograms. See, that is a nicer number than like moving the decimal point. What was it again? 70, and then what was it? 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, same number, but better. That's why I like this conversion factor thing. Okay, that's the way to do it, people. You could take all the shortcuts you want in life, but sometimes you just got to do it the right way, or at least know how to do it the right way, so that when you need to do it the right way, you can. And if you want to take a shortcut sometimes, like doing centimeters to meters, and you just want to move the decimal point, that's totally fine too, if you know the background knowledge. And that's about it. Thanks for watching and have a great day.